Public School. I'm your science teacher. We are learning chapter 3, atoms and molecules. Now, what we learned yesterday was law of, there are two law, right? Law of conservation of mass, that mass before the reaction and mass after the reaction will not change. Second thing, law of chemical combination means there, law of constant proportion means there, in order to have a compound, the atoms are always mixed with each other in some constant proportion, right, in definite proportion. So in a chemical substance the elements are always present in a definite proportion by mass. Okay, now the next problem the scientists faced was how to explain this law appropriately. Now we just know that John Dalton, right, provided the basic theory, right. Then Dalton picked up this theory and he took the name atom from the Greek, and then he gave a new theory, that Dalton's atomic theory. What he gave was Dalton's atomic theory, right. This is about his life, right. He belongs to a very poor weaving family in England. At the age of 12, right, he became teacher, and after 7 years he became principal. Now what is Dalton's atomic theory? In Dalton's atomic theory, what he is saying is that all matters is made up of very tiny particles, which we call atoms, right, which participate in a reaction. So who participate in a reaction? Atoms, right. Now atoms are, again, as what I said, they are indivisible. Also they cannot be destroyed or created in a chemical reaction. Then you must be wondering that if they do not destroy a chemical, how can a new compound is formed? They mix with each other, but they do not destroy. Okay, atoms of a given element are always identical in mass and in chemical properties. Also, atoms of different element have different masses. So different element have different masses because the atoms are different. Last, the atoms combine in a very small whole number or to form a compound. And lastly, the relative and the kinds of atom are constant in a given compound. For example, H2O. In water there is always 2 hydrogen and 1 oxygen, like this. So this is Dalton's atomic theory, where he is explaining us about atoms, that how they are and how they react, what are their properties and all. Okay, now next what we are talking is about the size. If we know so many things about atom, then what is the size of an atom? Then have you ever observed, like we know a building is made up of walls of a room, right, and a room is made up of bricks and all, right. Then how big are an atom, right? You're really surprised to know that atoms are very small, right, and atoms is beyond our imagination. If you see a paper, right, your book's paper, you see the thickness of the book's paper is so thick, right, it's very small. That thickness of a paper contains millions of atoms. Then think about the size of an atom. Thus I said, then atom has a radius of 1 nanometer. Now what is 1 nanometer? 1 nanometer is what? 10 raised to minus 9 meter. N stands for nano. So you remember what this means? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's like 0.00000. This small an atom is, right? We cannot even imagine. If you see, there are certain radius given to us. Plural form is radii. 10 raised to minus 10 is an atom of hydrogen, right? 10 raised to minus 1 is an radii of an atom of ant is, we are talking not ant and apple, we are talking about an atom of an ant apple grain or the hemoglobin, right? If then you must be thinking, sir, if atom is so small in size, then why do we care about it? But the question is, this our entire world is made up of atoms. Anything you pick up, they have atoms. Anything you pick up, they have atoms. And that is the reason we have to study those things, because at atomic level, if you study and you try to identify, you get everything into you can understand everything betterly, right? So right now, whatever the composite materials we are having, those composite materials is a building things, is a building block of all these things. So composite material, there's all these things what we are having right now here is all because of our atoms. Okay. So through modern techniques, we can now produce magnified image of surface of element showing atoms. Clear? So hope you are getting what I'm saying. So Dalton's atomic theory is very important. Second thing, you should know the size of an atom also. Fine. So basically the story starts with how does an atom come into existence, who find out it. Then we saw there are two laws. Then we saw Dalton's atomic theory, and finally we saw what is the size of an atom. Okay, so that's it for a day. You just study it very well and ask me any queries if you have. Thank you.